Solving rational equations. Here's the first problem. 2 over x plus 3 plus 3 halves equals 19 over 10. Bless you. So the goal of this problem is to find a value of x. So when you add that value to 3, take 2 divided by it and add 3 halves, you get 19 over 10. But that sounds much more complicated than what this really is. Here's the first thing we have to realize. We're going to go back to yesterday. Yesterday we talked about not having the denominator equal 0. If a denominator does not have a variable, there's no way to turn it into 0. So I don't need to worry about a denominator equaling 0 here or here. But in this position, what value would we have to exclude? Negative 3, okay? Just keep that in mind. If our answer is negative 3, then we need to exclude it. So keep that in mind. Okay, so here's how we do this problem. Here is the shortcut. The shortcut is we are going to find a common denominator since we're adding fractions for everything. So I see right now 3 different groups. There's really a hidden 1 here. So I see a 1, a 2, and a 10 for constants, and the quantity x plus 3. So I'm going to turn 1, 2, and 10 into the smallest number that we can achieve by multiplying. So does anybody have an idea? What number can I get to by multiplying in all 3 of these and be equal? 10. So do I have to change anything about the first one? But the middle one needs to be multiplied. We always do this by multiplying. You could do it by dividing as well, but generally by multiplying. Take the middle one times 5, so I have 10, 10, and 1 times 10. Okay, so 10, 10, and 10. Good, got that part. Then the next group I need to consider is the quantity x plus 3. It's not just x and then a 3. It's x plus 3 together. This has an x plus 3. This is missing an x plus 3. So I'm going to attach an x plus 3 to the middle section and to the last section. What I haven't stated that you need to understand is anytime you attach something to the denominator, the same thing must be attached to the top. Like attached to 5, a 5 goes on top. Or a 10 and a 10, an x plus 3 and an x plus 3. Now I have 10 times x plus 3, 10 times x plus 3, and 10 times x plus 3. Once the denominator is the same, this is why most people like this, it makes it easier, please put a line through the denominator, we're done. And now we only focus on the numerator. 10 times, somebody touching the cord accidentally? If there's a cord on the ground, you can't touch it or it makes that noise. 10 times 2 is 20. Plus 3 times 5 is 15 times the quantity x plus 3. There's a 19 and an x plus 3. It's the ghost. Okay, I'm going to distribute the 15 and distribute the 19. 20 plus 15x plus 45 equals 19x plus 57. Combining like terms, you can move the x's to one side and move the constants to the other. So I'm going to choose to move 15 over since it's the smaller of the 2 x's. There's no rule that says you have to move them to the left or to the right. And then I'm going to combine 20 and 45 is 65. You'll probably help me since you have a calculator. And then I'm going to subtract the 57 and I come up with 8. And the final step will be to divide by 4, and x equals 2. Then we need to analyze that, just to make sure, okay, we got an answer of x equals 2. It wasn't negative 3, I'm good. So what does that mean? It means if I take the value 2, and I plug it in for x, and I add 3, and then take 2 divided by that number and add 3 halves, I would end up with 19 over 10. This is the answer. Problem done. 1 to 5, how well do you feel like you're able to follow me with that problem? 1 to 5. Okay, if you feel confident while I start the next problem, you may work on your own speed and work ahead of me if you feel confident with that problem. 4 over x plus 3 plus 5/6 equals 23 over 18. And again, if you're feeling confident about problem 1, go ahead and try to do problem 2 on your own, but I will walk through step by step. Really, there's a 1 in front of the quantity x plus 3. So when I analyze the numerical values, I have a 1, 6, and an 18. The smallest number that they all nicely divide into or go into would be 18. So I need to turn this into an 18. Oh, already there. Make this an 18 by multiplying by 3. And make this an 18 by multiplying by 18. Now I have 18, 18, and 18. They need to all have the quantity x plus 3 that goes together. The first group already has it. I'm going to attach x plus 3 to the second group and to the third group. Now I'm going to cross out the bottom because they all have 18x plus 3, 18x plus 3, 18x plus 3. Cancel out the bottom, the denominator, and I'm only going to focus on the numerator. 18 times 4 is 72. 5 times 3 is 15 times the quantity x plus 3 equals 23 times the quantity x plus 3. I'm going to distribute the 15 and the 23. 72 plus 15x plus 45 equals 23 plus 69. Then I'm going to go through it and I'm going to move the x's to one side. So I'm going to move a 15x to the opposite side. The 15s will cancel. 23 minus 15 is 8x. I'll see if I can call back since I'm in the middle of videotaping. Okay, 72 plus 45 is 117. Okay, now to solve for x, I'm going to subtract 69 to both sides. Use a calculator and help me out. What is 117 minus 69? I think it's 48, but can you check? Then divide by 8. X equals 6. But what we forgot to do at the very beginning, before I started doing any of this common denominators, I wanted you to analyze, okay, 18 cannot turn into a 0 because there's no variable. 6 cannot turn into 0 because there's no variable. The quantity x plus 3 could turn into 0 if x was equal to what numerical value? It's not equal to negative 3, we're good to go. 1 to 5, how well are you understanding that one? Okay, so most of us are 4s and 5. We're going to go on to a different type. (2x over x plus 5 minus x squared minus x minus 10 over x squared plus 8x plus 15 equals 3 over x plus 3. Okay, so during this problem, I'm going to do all of the work and show you how we do it if we show all of our work. The next problem, that's kind of a mirror image of this, I'm going to show you how can we cheat, still get the answer, but not do as much work, okay? So let's start by factoring this. Two numbers that multiply to give 15 and combine to give 8 would be x plus 5 and x plus 3. So when I focus on the denominators, I have a group of x plus 5 and a group of x plus 3, but they all have to have the same denominator. So the first section is missing x plus 3. I'm going to attach an x plus 3 to both the top and bottom. And the last section is missing an x plus 5. Now before I go any further, looking back to the original problem that's in blue, what are the two numbers that we can't have as final answers? We don't want to have an answer that is -5 or, right, those are the excluded values. Okay, So I now have denominators that are all the same, so let's cancel at the bottom. I'm going to write down the numerator. It's important you put it in parentheses, this middle section, or you will get it wrong. Okay, I'm going to distribute 2x squared plus 6x. When I distribute a negative sign, it simply changes the sign of everything inside. And now when I move the 3x and the 15x over so I can combine like terms, moving over a positive 3x makes it negative, and moving over a positive 15 makes it negative as well. Okay, combining 2x squared minus 1x squared is 1x squared. 6x and 1x is 7x. But then I have to remember to subtract the 3x. So 7x minus 3x is 4x. And 10 and negative 15 is a negative 5. What factors to multiply and get negative 5 but combines to give you a positive 4? X plus 5, x minus 1. Okay, what makes this equal then? X equals negative 5 and x equals positive 1. But there's a problem. We have to look at our answers and go back up to the excluded values. Do either one of these answers belong to the excluded values? Cross out whatever one is excluded, and we only have one answer of x equals 1. They call this an extraneous solution. What it means is you do all of the algebra correctly, you get the answer, but when you check, it actually would break a math rule if we kept that as an answer, because you'd have x equals 0 in the denominator position. So we need to exclude it. Okay, the next problem that is much like it, I'm going to show you how can we do the problem but show less work. So we're going to go 1 over x minus 2, 2x plus 1 over x squared, plus 2x minus 8, plus 2 over x plus 4. Okay, so here's the shortcut. You ready? We are going to factor this. This factors into x plus 4 and x minus 2. So what values would we need to exclude? Our final answer cannot include a 2 or a negative 4. Keep that in mind. Again, what I do now is going to be, I am going to simply go, what is the short way of me doing this problem? Okay, what does this first section need for it now to have a common denominator? Okay, so I'm going to put down the 1 and then write x plus 4. I'm not going to write the denominator. Does the middle section need anything to have a common denominator? Write down exactly what you see. Does the last section need anything to have a common denominator? It needs a x minus 2. So I've actually kind of mentally found a common denominator and eliminated the denominator. This is what I have in the numerical value, as a numerical value. So I'm going to distribute the 1, which doesn't change anything, distribute the 2, and then I'm just going to solve for x. So 7/3 is not in one of the included values, the excluded values. So we're okay to have that as a solution. We have 3 problems left. The next 3 problems, I'm not going to provide a secondary problem that is similar to it. Here's the first one. 1 over x plus 1. My fault, 2 over x plus 1. 2 over x plus 1 minus 1 over x minus 1 equals negative 2 over x squared minus 1. We're going to use that shortcut method that I just showed you last, where we find a common denominator kind of in our minds, and we cancel out the denominators in our minds. But you're welcome to show all of your work if that's what you prefer. So what does x squared minus 1 factor into? Okay, so in your mind, you're going to think, what is a good common denominator? Miguel, what's a good common denominator when you look up here? What did you say? There has to be some, so you're going to look at these. Can somebody help Miguel out? What's a good common denominator? Anybody? X minus 1 and x plus 1. Okay, so let's go off to the side really quickly. What solutions have to be excluded? Negative 1 and positive 1. What is this term missing? If we want a common denominator of x minus 1 and x plus 1, well, this is missing a. Okay, so I'm going to put 2 times x minus 1. Then I'm going to bring down the negative 1. What is the middle term missing? Negative 1 times x plus 1 equals negative 2. What is the last portion missing? Nothing. So I'm going to distribute a 2. I'm going to distribute a negative 1. And then I'm simply going to solve for x. I achieved an answer of x equals 1, but when I checked with the excluded values, that was one of the excluded values. So I have to cross it out, meaning there's no answer, so I write down no solution. Okay, we're going to go on. We have 2 left. Here's the next problem. 5 divided by the quantity x minus 2 plus 2 equals 17 over 16. What value is underneath the 2 that we currently don't see? And really, what value is in front of the quantity x minus 2? Okay, so I have, just thinking about constants, I have a 1, and a 16. What would be a good number then? 16. Okay, so I'm going to do it the shortcut way right now. What does this quantity need? 1 times what gives you 16? So I have 5 times 16. Now, this is the problem with this one. You need to get this up to a 16 by multiplying, plus you need to attach x minus 2. So 1 times what value is obviously 16? Okay, plus we need to attach the quantity x minus 2. And now I have the number 17. I already have a 16 in the denominator, but what else needs to be attached to that quantity? X minus 2. 5 times 16, I believe, is 80. 2 times 16 is 32. I'm going to distribute the 32 and the 17, and then combine like terms and solve. did anybody else get the same answer when you reduce it down to negative 10/3? Anybody? Did anybody else get a different answer? Okay, looks like you probably needed more time to finish. One problem remaining. A different answer? What'd you get? Negative what? So that's what I have too. You get the same thing. Okay. All right, on to our very last problem. 3 over 2x minus 9 halves equals 6x. What is below the 6x that we cannot currently see? Anyone? A 1. So let's forget about just the x right now. Let's look. We have a 1, a 2, and a 2. So they all need to turn into at least 2. So I'm good, I'm good. This needs a 2. So again, if you want to do it the longer way, you're welcome to do that if it makes a little more sense to you. Now they all have 2's, but they also need to all contain an x in the denominator. Whatever you do to the bottom, you must also do to the top. Once the denominators are all the same, we're going to cancel. 3 subtract 9x equals, now this is a little trickier, 12x squared. Remember, our goal is to solve for x, to find out what is the x value we could substitute in to have the left side equal the right side. Going back to the original problem, I know that the excluded value is 0 because 0 times 2 is 0. So I'm going to move everything to the same side as the x squared. When I move the 9 over, it becomes positive. When I move the 3 over, it becomes negative. All of these numbers are divisible by 3, so I'm going to factor out a 3. And then I'm going to focus on this trinomial. I'm going to factor just the trinomial inside, not the 3 that's been factored out. So what multiplies to equal negative 4 and combines to give you a positive 3? X plus 3 and x minus 1. But the common mistake students will make is forgetting to divide by the leading coefficient, which is 4. What makes this equal to 0? Negative 1. What makes this equal to 0? Positive 1/4. Neither of those answers are included in the excluded solutions. So we have 2 solutions for this problem.